You want to get out of that firefighting mode of trying to react to all our problems. So what can we do differently? Well, first of all, we need to look at things a little differently. Quality should be, and safety should be the number 1 things that we look at. We should be an active part of our solution, and we must fix things as soon as possible and invest into some prevention. Try to be as proactive as possible. And we have to set up a system to do that. Now, let's talk back about your car. Your car just passed 30,000 miles. So a service check is recommended, even if it's running fine. Why? It's to prevent problems, to check it out. Does everybody do their service checks on their cars? Probably if it's covered by warranty you do, but as soon as warranty's out, what happens? You stop. Typically. Not everybody does. Okay? So we want to make sure that we check the operation out. Now, how many people have to get to work in the morning on time? What happens if you didn't do the check on your vehicle and it broke down? Is that an inconvenient time for it to break down? What if you're going to the airport to catch an air flight out? Is that an inconvenient time? Going to a soccer game on Saturday? Is that an inconvenient time? Usually what happens is if we don't maintain our piece of equipment, the breakdown will happen at an inconvenient time. Right? So let's prevent that. So we want to set up systems where we don't have that. So we want to check. It's also a pay me now or pay me later. Typically it's pay me more later is what happens. If you have a major pump repair, if you have an unplanned, it probably takes you about 200 hours as an example of downtime. It'll cost about $60,000 to replace it, usually 10 times the normal cost. Why? Because you have overtime, you have to expedite it, you got some shipping, you can lose production, you got outside help that comes in. There's all things that you have to do to firefight to get things done fast. If you didn't have to do that, maybe it would only took you 72 hours of planned downtime, and you would have had things planned up front that it could have cost you less, maybe $6,000. Those are just figures as an example. But you can do the simple math that any time that I can plan something, it's going to be cheaper than if it was a reaction to something that happened at an inconvenient time. So the point is, how can we prevent those inconvenient times happening? It also can save us energy. You can go into some super equipment, and this is something when you get further along in the TPM to start looking at prevention, investing in things like ultrasonic equipment, vibration equipment, thermographic, and oil analysis. Let's take oil analysis as one. One of the things about oil analysis is, just like you change the oil in your car, what do they tell us? Change your oil every 3,000 miles or 3 months, right? It's in the manual. Why do they tell you to do that? History. Okay. Neither one is the best way to do it. The best way to do it is look at the oil itself. The oil will tell you, is it needed to be changed or not? Okay? So it may be 6,000 miles. Not 3,000 miles. So they're using that to ensure that you can change the oil without checking it. We may do that in our equipment. How many people say we're going to change that every 6 months? Or we're going to change that every so many hours of production? It's typically how maintenance has it set up. What you may want to look at is how can I analyze my oil, both send it out to be analyzed or do it in-house. That way I can check the oil condition and it can tell me when it really needs to be changed. Save you time on the changing the oil and saves you time on making sure that it doesn't wear out prematurely. Now let's talk about maintenance heaven. If you're thinking about maintenance heaven, what would be heaven to a maintenance person? This is a family channel. Okay? Okay. Yeah, 0 breakdowns. That would be good, right? You'd be in heaven if you had 0 breakdowns. You didn't have any setups or adjustments to worry about on any pieces of equipment. That'd be heaven. You had no small stops, little interruptions, little hiccups that you got to run out and go fix this lever. No speed losses. You have a piece of equipment by speed loss, what I mean is the machine's old and we can't run it full out. Let's back it down about 80%, maybe 60%, because we don't want to push it too hard. So that's a speed loss. We have to slow the machine down because it can't handle running it what it's meant to be. Startup rejections. Yeah, we got the machine set up, but we got to do a lot of adjustments to get a good piece out. So all those adjustment periods. Any product defects that happen because the machine doesn't hold the variability that it should hold. So our tolerances are too tight and the machine's not capable of running those tolerances. So we got a lot of rejects. So I would consider those the big major losses. Those are the 6 major losses that we look at And if we didn't have those, we would be in maintenance heaven. Would you agree? Okay. So when we look at those 6 major losses, we can actually measure them, something called OEE. And what we're going to look at is how those losses affect our production. So if you look at the very first top chart, our total production time is, we can run all out, complete time to run the machine. It can run 24 hours, 7 days a week. Our availability loss is things like if we have breakdowns or we have setup adjustments, well, we got to make time for that. So whatever time that we lose for breakdowns and the setup adjustments, we lose availability. So if we subtract that from our total time, then we have some remaining operating time. Then we come back and look at minor stoppages or reduced speed. That's a performance loss. We slowed the machine down. So we take that off, and then we have less operating time. And then you look at any time we have reworks or startup issues, that's a quality issue. And then we take that loss off, so we are down to less time. So if you take all those losses during the day, and you see how much time does our machine actually is available running at top speed and running good quality parts. What percent of time is our machine running that way? We want to make that a larger percentage of the day than what it currently exists. Okay? So here's a piece of equipment. It's on the logbook saying it should run for 6.5 hours. During those 6.5 hours, there was one die change, took 30 minutes. One downtime incident took 90 minutes to repair. The operator had to wait 60 minutes for additional parts to be delivered. There were 63 parts made, but 3 were rejected. So based on what we just talked about, we can measure what the availability time on that machine is, what the performance rate is, what the quality rate is, and then what's the OEE. So our OEE basically is doing the math. We took our load time of 6.5 hours, which is 390 minutes, subtract the die change and the 90-minute stop. So right now, dividing that out, it's 69% available. So we took the losses of the setup and the breakdown of 69%. Performance was down to 78%, and then when you looked at the quality, it was 95%. You take those 3 and multiply them by each other, the 69 times the 78 times the 95, gives you 51% OEE. Overall equipment effectiveness. Now, a lot of times we want to measure how effective our equipment is, so we institute a measure on our pieces of equipment. Usually when you first start a TPM program, you don't know how effective your equipment is, so you don't have this metric. So it's a good metric to start so everybody understands what the process is of where our losses are coming from and what can we do about it. As you get really good, it may become a point where you don't need this metric anymore, but it's a good metric to start out with so everybody understands what's causing our machines not to run at full out. Typically in the US, it's about a 40% running time. So 40% of the time, you would expect our machines running if you did the true OEE on your equipment. So what's world class? World class is 85%. So if you're at an 85% level, that's pretty much world class. Of course, we want to move it toward 100. Now, what happens if you have 120% OEE? Fix your standards. Exactly correct. We had that example happen to us. We had an OEE of 120%. So when we went through and looked at each of the elements, we found out that the standards that were set for the machine were too low, that they had changed some of the tooling and improved the productivity, but never changed the standards. So they're kicking butt on getting the productivity out. They're still terrible on the other stuff, but they were so productive when it was running, it had 120%. So what did we do? Change the standards. Reflect what it should be running. And then the OEE was back down. So you may run across that. But when you did the measures, you saw that problem. Even though people knew about it, they didn't figure it out until they did the OEE and said, oh, we should change that. We should fix that.
So every time you improve it, you're going to change the standard?
No, that was just an example of where we had changed some tooling to improve the productivity, and it was reflected in the OEE. But you would do this metric and see where your losses are and concentrate your focus on the biggest losses. Now, the biggest loss of all is if you have a loss of life or an injury. So make sure safety's first when you do a TPM program. Make sure you do the lockout, tag out, and whatever safety procedures that you have. So we talked about the 6 big losses. That's nothing compared to this loss here. We don't want anyone losing or being injured in our equipment.